as a way of introduction, a few notes about this gentleman, which are pretty cool. So I actually first had a chance to see this guy do a talk. I think at some point last summer at a meetup. It was pretty cool. But I think like my favorite anecdote and what will be for the longest time was last year we had a very sudden scheduling misfortune whereby we had a Kotlin workshop planned for the afternoon. And unfortunately, the speaker that was supposed to be doing that had to suddenly go. And this guy came up. He's like, "I'll do it. I'll jump in. I'll run the workshop." I was like, "Whoa, man! I think that's like a crazy idea." But you know, really kind of meant a lot to me. And so also, I think this year he was one of the first speakers that we were able to kind of arrange to have join us today. So. Please, everybody, a really warm welcome talking to us about A Skeptic's Guide to Programmatic Views on Android from Square, Mr. Adam Erb.
Hey, yeah, so this is my, my quick little rant, my old man rant on programmatic views in Android. So I think I'll start with the start. Probably a lot of you are wondering what programmatic views are, what I'm talking about. So I like to tend to start with definitions. So I think the first definition I want to talk about is like your declarative UIs, which in my mind is the more standard way of creating views. And this is to declare structure and style in kind of a declarative way. In Android, this would be to use layouts, drawables. In iOS, to use storyboards. This would be HTML. And this is basically using object models to kind of render things, and it tends to introduce higher levels of abstraction. You kind of have concepts of like float, of nesting, and stuff like this. So kind of the flip side of that is programmatic UIs, which is something I've had a bit of experience with. And this is when you write your UIs more in an imperative language, like so Java or Kotlin or Objective-C. And it's working more directly with APIs like the Canvas, like Quartz2D for iOS, or even just OpenGL. And it's more about like ordered, draw, transform, clip commands. And you have kind of like a lower level of abstraction. So really what I want to do is I want to make an argument for programmatic UIs. Because declarative kind of won. Like it has a lot of like very approachable things about it. It kind of tends to have this mental model which makes sense to us. And with this comes kind of good tooling because it's like a little bit abstracted from the platform. But I think there's some issues with it. It can be inflexible at best. And at worst, it can just be the outright wrong abstraction. So when you're doing stuff more programmatically, I think there's a couple like key benefits of doing stuff just in code. And there's a couple things. Like the first one is like a homogeneity, which is maybe a weird word to bring up, but what I find is like you're not working anymore with like your code and your resources and all these drawable assets. Instead, like there's kind of a power of working in one thing, and I think that can actually be really beneficial. Second is discoverable. I find you tend to work less with like these kind of hierarchies. You're not thinking about like all these different types of drawables or all these different types of layouts, and instead you're just focusing on like a simple set of drawing commands that you learn how to use. And then finally, it's incredibly flexible. If anyone's ever tried to create custom views, this tends to be the way you want to work because you kind of, there's less abstraction, but you build the abstraction that you want. So in Android, when we talk about like declarative UIs, three things seem to kind of jump to my mind. This is first of all is like the layout system, like kind of the standard layouts that we use to position and measure out our apps, like your constraint and relative layouts. This might also be drawable XML resources, kind of those assets that you import and then use to draw things on your UI. Or finally, like gesture handling, like just a simple way of saying like, okay, I want I want a long press listener, but what if you want to do more? What if you want to tweak this in some way? And I think there's things I dislike about each of these systems. First of all, with standard layouts, I feel like it turns like a pretty simple layout mechanism into like kind of complex rules that you see in like constraint and relative layouts. XML resources basically replace a very simple drawing API, Canvas, with like an object model. And gesture handling is just inflexible. And if you have multiple gesture handlers fighting together, I find this can often be like really glitchy and kind of be a pain to work with. So for this talk, I'm really going to focus on the three things that I think we should in fact be focusing on, the overlooked alternatives in Android. And this is that standard layouts, so your constraints and relative layouts, in fact, rely on the layout system, which I think is really worth learning about. XML resources, you should just use Canvas and learn about that. And instead of like gesture handling, like let's look a little bit into how to create custom events using the event system, or sorry, yeah, custom gestures using the event system, and we can build from there. All right. So first thing, the layout system. And in Android, this is how you position and size all views. Layout in Android is two pass. First pass is a measurement phase where you kind of figure out how big things are. And then the layout phase is where you actually decide where things should be positioned. Layouts requested using the request layout method on view, and this will cause like then a full tree traversal to get everything to update size and position. So to hook into your measurement phase, you override a view or view group, and you override the onMeasure method. And this is passed in width and height measure specs, which kind of dictate the way that you should size yourself. Then the only rule for this method is you must call set measured dimensions, which is kind of declaring how big a view's size is. And then this in turn sets the measured width and measured height fields on your views, which can be used later. And if you are a view, like a view group with children, it is also your responsibility to call the corresponding measure method on each child view just to kind of propagate, to continue this traversal. So one word I used was MeasureSpec, and this is a way Android uses to communicate sizing requirements from a parent to a child. It's basically just an integer, but it's treated specially in that the top 2 bits are designated to mode, and the remaining are size. Mode can be a series of things. It can be unspecified to basically say parent view to child view, I don't care how big you are. It can be exactly, saying like this is how much space is available. Use exactly that. Or it can be at most, to basically just say like this is what's available, use up to that but no more. It gets combined with your physical dimensions, like maybe screen width, and then that's how a parent communicates to its child how to measure itself out. And if you're dealing with this in practical terms, usually you want to use the MeasureSpec class, which has a make MeasureSpec method, which takes in a size and a mode, returns a spec, or get mode or get size, which takes in a spec and return the mode or size. And while we're on the topic of density agnostic measurements, I also just want to quickly divert to, while we're talking about measurements, I just want to talk about density agnostic measurements. And this is a problem that like 100 pixels on a 160 dpi screen may be fine, but on a 640 dpi screen is like unusable, like effectively 1/4 the size, physical size. So to deal with this, Android also gives us the display metrics class, which exposes size and pixel density, stuff like this. And built-in conversion comes in your XML resources in the form of like points, dip, density independent pixels, or inches or millimeters. This basically allows you to convert like a physical size unit to your pixel equivalent. And in your XML, you simply put the suffix, the unit suffix, on the end of your value, and then this is kind of converted under the hood. But programmatically, it's like a huge hairball. You have the typed value class, and that's kind of what's recommended to do your conversions. You have typed value, and you call a method apply dimension. It takes in a unit, a value which you want to convert from, and then an instance of display metrics. And like the usage for this is just like god awful. It's gigantic, and if you're using it like in a lot of parts of your application, I think this can actually be pretty nasty. But there's an alternative which I actually recommend if you're doing a lot of this work, which is that you can just pull out the display metrics and the density from your application, save it in a field, and then basically just roll your own function for doing these conversions on the fly. And then you can have like a nice terse way of doing these programmatic conversions from a physical unit to then a pixel density specific unit. So that was everything about layout or about measurement, but what about layout as well? This is the second phase. So to perform this, you also need to subclass view or view group, and you implement the onLayout method. This takes in the newly populated left, top, right, bottom parameters. And really, there's not too much you have to do if you're simply a view, but if you're a view group, it is, again, your responsibility to tell your children where they're going to be laid out relative to yourself. and pass in the corresponding layout method to those, make that call to your children in order to continue this layout traversal. A good thing to know is that like all coordinates are relative to your parent, 0, 0 being the top left. So that tends to simplify your layout logic quite a bit. And also a thing of note is that the layout method takes in like a left, right, top, bottom parameters, which is a little bit strange because it's like we've already figured out what our width and height is. It's in measured width, measured height because we've just gone through a measured phase. So what I tend to like to do, and what you'll probably see in some of the examples coming forward, is you can simply define your own layout method, your kind of override, where you just take in an x and y, you take in this implicit measured height and measured width, and then based on that you can kind of figure out what your layout rect is going to be. So this is like a way of like avoiding some of the boilerplate I find, which I like to use. Okay, so I've just been like talking just all this detail at you for about 10 minutes. So like let's dive into an example where we can actually see some code. And I think the internet is like a pretty like maybe not always the most positive thing, but like I think cats are maybe the one example, the one net positive takeaway. So what I've defined here, which I'm going to implement, is like a lolcat activity that just takes in like, you know, from a service it takes in like a list of lolcats with some description, and the view here is like just a linear layout, and you have some smaller children which represent your cat view, and then yeah. So how do we go about creating this thing? And also the constraint here, right, is that we're going to do this like fully programmatically, not use any like standard layouts, nothing like this. So everything is coming from scratch. So first thing we got to do, like we define a vertical layout. Like we're not even going to use linear layout. This I don't really recommend because linear layout works fine. But you know, for demonstration purposes, let's just go for it. So we write a linear layout. It has some concept of padding and spacing, and it has children views, like a LolCatView. And this has like an image view, which is a static size, a text view, which is like variable, and then like a likes badge, so you can tell like how many people like this cat. So like how do you go about like creating the thing? Like fully in code, no XML, nothing, no layouts, nothing like this. So first thing's the measurement phase. And with the vertical layout, your top level view group, so it's actually pretty straightforward. You can basically make the assumption that your top level, your parent's going to pass in for a mode, like just kind of at most. It's going to pass in like an exactly at most. And you could kind of treat the else condition where maybe you throw or maybe you base your height based on your children. But for this, we're going to simply assume when you do set something as a top level view, it's basically just going to get passed in the screen dimensions that you work from. So we set our proposed height as the size given to us, and we do the same for height. Or we set width to the proposed width and height to what was passed to us. We call the kind of special set dimensions method with these newly calculated width and height. And then we iterate over our children. Since it's a view group, it's our responsibility to call the corresponding measure method on the children. And for this, we have to also provide the new measure specs for these children, dictating how we want them to lay themselves out. So in our example app here, like we want to kind of have it be the size of the parent view, but like minus some padding. So we pass in like measured width minus horizontal padding, and we basically, for mode, we say like just do exactly that. And then unspecified for the height because it's a vertical layout, and there's like effectively no maximum height. Like if you go past the screen bottom, you can scroll further down. So for height, like just do whatever you want. And then for the actual like cat views, I want to add some additional like more complex constraints, which is that like okay, if this thing is a small amount of text, like text is like really what makes layouts complicated. It's variable in size. So if it's a short amount of text, the thing is the size of the image. But if there's a ton of text, then the view expands with that text and centers the image vertically. So keep that in mind while we like kind of go through the measurement phase of the LolCatView. First thing you want to do is you just want to hit the children that you know to be constant. So we know image view is a constant size. We just set it as an exact 60. Same with the likes view. It's just going to be an exact value. So nothing really affects that. But like we have to address the unknowns. The unknowns being we don't know how wide this LolCatView is going to be, and we don't know how wide the text view is going to be. So we pull the width available to us from getSize, MeasureSpec.getSize, and then we use this to derive how much remaining width there is by subtracting that value from the image view size. Great, now we can plug this into the text view measure, and basically what that then gives us is the ability to pull out, based on the text inside the text view, the measured height for calculating our layout. So now we have the height of our text view. We can then plug this into the set measured dimensions method on our view, and plug that into a max function, and then pretty much just set the view of your LolCatView to either be the maximum height of your text view or height of your image view. Whichever is bigger defines the height of the parent view. So this thing's all measured out now. This is like how you kind of dictate measurements in a simple application. That brings us to layout, which is fortunately a little simpler. Layout is simply a matter of, now that we have our measurements, we kind of define some like starting y and x coordinates. We then iterate over the children and call layout on them with the method I kind of talked about previously, simply defining like x to be the x variable and y to be the y variable. And then you update y as you iterate, just with the height of the previous child plus the spacing concept that we want to introduce as well. So you're laying things out one after another at the bottom of the previous view with some additional spacing. You call layout on the LolCatView, and then this in turn triggers on layout on your LolCatView. And we have to handle our kind of special layout logic where we lay out things out based on the image view height and the text view height. So image view, if the image view is larger than the text view, then we lay out both aligned with the top, the text view aligned right of the image view. Otherwise, we lay out the image view centered vertically with the text view aligned to the right still at the top. And the likes view is like always top left, so you don't have to think about that too much. And then that's like the full layout, like a fully programmatic way of defining the thing. Really like just working from the bare bones in Android. And what I like about this may seem like kind of a crazy example, but I think it can scale up really well when you have complex ad hoc layouts. And so basic math gets you a very long way, which is something I really like about this. You're not thinking about any kind of crazy like floats or like kind of constraints anymore. It's really like what's the physical dimensions between these two views. Like it becomes fairly simple with basic math to go a very long way. It can be great for custom layouts. So if you ever want to define, like, don't define your own linear layout, but like if you want to define a floating layout, if you want to define a spaced layout, this can be like this is probably your only option for doing this. And it's really great for compound views as well. I think this is actually like a seriously good alternative to relative or constraint layouts. It can be. And if you ever feel like you're in a scenario where you're like combining together too many views, like you have a linear layout and a relative layout, that maybe indicates that like maybe you should have something more custom. And this can be an awesome way to avoid nesting. And with that, kind of get some performance benefits. So that's like kind of the whole layout system. So like that brings us to Canvas. Like how do we want to talk about how can we draw things in Android using a more programmatic way? And Canvas is simply your lower level drawing API. It's basically the Java front end for HW UI, like the Google C++ drawing library. And it provides like a bunch of commands that allow you to draw to a native bitmap buffer, or like to issue OpenGL commands. And this is basically what every higher level component uses in Android. Your views, your drawables, all that stuff. So if you want to take advantage of this, you again override view or view group. And you override the onDraw method. And then you manually trigger draw by calling invalidate, which kind of tells Android, okay, this view wants to draw itself. OnDraw is then called, and you get an instance of Canvas passed to you. And Canvas takes in like has a bunch of methods of like the pattern of like draw line, draw rect, draw oval, draw text, which all take in some geometry and then an instance of paint. And paint can describe color, can describe path, style, fill style, shaders, stuff like this. And additionally, there's draw path. And path allows you to chain together coordinates to make kind of like more complex shapes. So you can do like line 2, cubic 2, arc 2, add oval, and it allows you to do transformations on these points too. So it's like a really great way of building one-off kind of UI components. Maybe that are like too dynamic for a designer to just give you a bitmap to use. So like we jump back to our example, we have like our lolcat activity. But like let's say that like now we want some interactivity. So we want the user to press on a cat, and then this triggers like a like button to pop up. And the like button kind of has this like weird little shape to it. It's like kind of rounded rectangle with a point at the top pointing at the lolcat that you're going to like. So like how do we define this? And from my experience, I've found that like when I kind of Google like how do I create a shape like this, I tend to end up in kind of this sort of like Stack Overflow hellhole where like people are just like copying and pasting XML, kind of hoping that the thing kind of makes the shape that they want. And that's kind of this approach here. So like in Android 21 or earlier, like you're probably gonna have to use a layered list with this approach. And this just allows you to combine shapes together. So you can define a rounded rectangle, and then you can kind of define another rectangle which you have to rotate and you have to like push into place. And that's kind of how you make it work. But already it feels like pretty awkward to me, and like a little bit like this thing isn't gonna scale well if complexity increases. And then also, let's say we want our button to be pressable, right? Like it should change colors when the user presses on it to kind of give some visual feedback. Well, okay, now we just like plug the thing into a selector, and now it's like even bigger. And I think this may be like a straw man. I think you can pull out the shape into another asset, and then you can reference that. But like now you have 3 files. Now you have like a shape file, you have like a selector file, and then you have your final file, like the view where you actually set the thing as a background. So it's like you have like 3 files for like this very simple idea, which I think is like crazy. So Canvas is just like a refreshing alternative to this. It's like very straightforward. You override your view of choice, set your initial values, and you implement your onDraw, or you override your onDraw method. Make sure to create an instance of paint, override onDraw, set the color of your paint, and then pass in a path of your drawable to Canvas, and it'll render itself. And like the path definition is very straightforward. It's declared here for the same example previous. And really all it's a matter of is like defining the 3 points which make up a triangle, and then like adding a rounded rectangle, and like you're done. That's the whole thing. And now what's great is that like, okay, let's make the thing stateful. Let's add it. Let's change the color. Okay, you like override dispatch set pressed, invalidate to trigger your onDraw to get called, and then you change the color based on your isPressed state, and like now the thing's stateful. So yeah. So what do I like about the thing? I think it's really flexible, and it's good for stateful stuff. But like even more, it's like let's say we want to like animate that view. What if we want the colors to animate? What if we want the shape to animate? Like you're always going to end up here. So why not just start here? And also like now instead of thinking about like, okay, in the previous example we had like a layered list, we had a selector, we had shapes, we had transformations. Like these are all drawables. Now we just have like Canvas, like a couple of like simple methods. So it's like you're thinking about like one simple thing rather than like a bunch of different things. So I like that too. And finally, like the main argument against this is you don't really get a Android Studio preview. But I don't think that I've never seen like a sufficiently complicated project where the preview is actually like working very well or giving me much useful feedback. So I feel like that's kind of a moot point. And then yeah, finally like we've like created layouts, we've created views, or we've created like kind of drawables. What about events? Like what if we want to do like custom kind of gestures, right? So if you don't want to use just like your standard gesture handlers, you want to use the motion event class. And this class can be a little bit intimidating, but if you know what to pay attention to, it's actually pretty straightforward. So this class will contain like an action, like it can be kind of like up, down, move, canceled, and some coordinates, kind of where the touch event happened. It can also have multiple pointers. It can have historical data. The multiple pointers are for like if you have like a multi-touch gesture. It can have peripheral info if like there's like some device attached to your phone. But we can ignore all of that. We can really just like work with action and coordinates, and that'll get us most of the way. So to actually like create a gesture, you override on touch event. Any event and any motion event that happens, like a touch to the screen, is basically dispatched top down the view hierarchy. But children's at the bottom of that hierarchy get the first ability to handle this thing. So they basically return true or false if they're interested in handling this gesture. So we're back one more time to our application. And before we had like a like button, but let's say that we don't want a discrete value anymore. Let's say we want like, we want a like measurement from like 1 to 10. So what do we introduce to do this? Well, we introduce a slider, and that kind of gives us our left to right, like how much do you like this cat? And when the user finishes, then you like save that to a backend. So if we want to implement this, the first thing we do is again, we override our views on touch event and hook into this touch event system. And the first thing that really any gesture is going to be interested in is action down. It's going to be like the user press something. Most likely is what 99% of gestures is going to start with. So let's start with that. And then how you proceed can either lead you down a route of like a horrible rat nest or something that's pretty easy to think about. And from my experience, what I found is that if you're writing custom gestures, state machines actually are like a really great way of representing gestures. So in this example here, like you just define a state of initial, waiting, and active. Oh, actually, before I get to this, I think I need to talk a little bit about the gesture I want to create, which I maybe didn't go into detail about. Like I want the user to like press on the cat view. They hold down after like a certain period of time. This then fades in, like animates in our slider. And then in the same motion, they have to like slide left or right how much they like this thing. So it's all one gesture. It's kind of custom. Like you could do it combining other gestures, but I think, let's say we just want to do this as one solid motion. Okay, so back to our state machine. We have an initial state, a waiting state, and an active state. Initial is just like, okay, like we're waiting for the gesture to begin. Waiting is like the user's finger is pressed and we're waiting for the time period to elapse. And then active is like, okay, we're actually taking in values now. So you initialize your state, you throw a switch function into your on-touch event method, and now you can like kind of think about things independently, like one state at a time. And I find that very helpful when you're defining these things. So first things first, like let's do the initial. You're looking for that initial action down. You then move the state forward to waiting. And you schedule a callback, basically, to animate in this slider. Great. Now we're in the waiting state. Really, all you're doing is like, if you see events that indicate that the gesture has been canceled, like maybe a up or a canceled event, that means okay, the users move their finger off, so we'll just cancel the thing. Otherwise, if we just see movements, that probably just means their finger is moving around, so whatever, we'll ignore it. At this point, hopefully the finger is still down. We get our callback scheduled. We check the state. If it's still waiting, we show the slider. We move things forward to active. And now we're in the active state, and we can actually like take in input and like look at the values. So if you see an action move, you just update your slider position. If you see an action up, that means the finger's been raised. We take that final value and save it. Hide slider bar, return to initial state. And finally, like, if it's anything else, if it's anything unexpected, I think it's always good to return to the initial state and kind of bring everything back to before the gesture initiated. So you might see a canceled or something like this, which can be an indication that a parent has canceled its child's gesture. And like that's the whole gesture then. Like you can model these kind of complex interactions just with like a simple like initial state. You're then like pushing like in the waiting state, then that like slider pops in after a certain period of time, then you're in the active state where you're actually taking an input, and then you're done. So I find it like a really good way of breaking like a complex gesture down into like simple components, and it can be really great when you're dealing with lots of views. I guess that's the next slide. Yeah. So why is this thing good? Yeah. So like. Yeah, I mean, again, don't like re-implement long press listener, but if you're doing anything customized, this is really good and probably the only way you have forward. And if you have like multiple gestures you're trying to coordinate together, this is also like a good option. You can override motion event behaviors, and you can coordinate two subviews to work together. Like maybe if you have multiple nested linear layouts or scroll views. You can then coordinate the scrolls in a nice way. Gestures model really well with state machine, and single touch gets you 99% of the way there. There's a lot of scary stuff in there, like multi-touch and like historical data. But like you don't have to take advantage of that. You can get away with just doing simple gestures, but if you want to, you can always take advantage of those more advanced features. So like. Overall, like those are kind of the three things I want to outline. So like that's the whole thing. Like why am I talking about this? What's the point of this? And I think kind of my rant here is that like Often I feel like we're like fighting with kind of like, do you ever use anything like a library or a framework, you just feel like you're trying to make it do something, it doesn't want to do the thing that you want to do, and it's just like a back and forth. Like often that means, I find that indicates that you're working with like an ill-fed abstraction, and maybe that indicates that you should go like a lower level and just like use the underlying things, because you can build the abstraction you need, which I think is very powerful. And when you do this, it gives you more control, it gives you understanding, which is something that pays back, you know, in multiples. Anyway, I find you have less SOD development, which is something I'm pleased to say I think I invented like before this talk. Stack Overflow driven development. I just feel like when I'm programming in this way, I'm not Googling stuff anymore. I'm not like looking at Stack Overflow. Like you just kind of look at a screen, you look at a layout, and just like, okay, like I know how I'm going to do that. Like I know the basic principles. You're not like Googling like, okay, like which drawable do I need to combine with this drawable to like make this thing. Like it just feels like much more clear. And I also like that UI code then becomes first class. You're not kind of like moving everything over into like XML. Like it's treated as first class code like the rest of your code. It can be tested. You can deal with static typing, and so you can leverage a lot of the benefits of this. And also, I guess this is like a side note, but like XML like just feels like it's like turning slowly into an imperative language in Android just because it doesn't do what we want to do. So now we're like adding stuff to it. And finally, even if you still think I'm crazy and remain a skeptic, I think these things are still worth understanding because it gives you like just a solid understanding of the underlying principles. It's really worth understanding how these things work. So so thanks for listening to me rant. Before people clap, I got put in the small room, so I want everyone over there to feel like they wish they were here. So like, please clap like really enthusiastically.